Welcome to this DelfStack tutorial. Today we will discuss how to calculate the curvature using NumPy in Python. We'll start by understanding what curvature is and why it's important. Then we'll dive into calculating the curvature of a curve. Once we have that foundation, we'll learn how to curve the curvature itself, essentially adjusting how much the curve bends. Finally, we'll visualize the results to see the impact of our manipulations. Let's get started. Curvature represents the rate of change of a curve's tangent vector, essentially measuring how much a curve bends. It's crucial in various fields including physics, engineering, and computer graphics for tasks like path planning, surface analysis, and object modeling. To calculate curvature in Python, we'll use NumPy for numerical computations and SciPy for advanced mathematical functions. Let's start by importing these libraries. Now let's define our curve as a function. For this example, let's use a simple cubic function. Then we need to calculate the first and second derivatives of this curve. We'll use the derivative function from SciPy for this purpose. Note that the derivative function takes 3 arguments: the function to differentiate, the point at which to evaluate the derivative, and the spacing between points for numerical differentiation. We're using a small spacing for better accuracy. Finally, we can calculate the curvature using the mathematical formula. Now let's test our curvature function with some sample points. We display the result, which is an array of 100 curvature values, one for each point in our X array. These values represent how much the curve is bending at each point. Now let's curve the curvature. We can achieve this by introducing a scaling factor to control the curvature's intensity. By adjusting the scaling factor, we can amplify or diminish the curvature, effectively controlling how much the curve bends. This technique is valuable in applications like computer graphics, where you might want to exaggerate or soften curves for artistic effect. Let's add this to the code. We've added a scaling factor parameter to our curvature function. By default, it's set to 1.0, so the curvature remains unchanged. However, we can adjust this factor to amplify or diminish the curvature. Let's use this updated function. Here we're calculating the curvature with 2 different scaling factors, 0.5 and 2.0. This will allow us to compare the effects of reducing and increasing the curvature. As you can see, the values in K1 are smaller than those in K, indicating a reduction in curvature. Conversely, the values in K2 are larger, indicating an increase in curvature. To visualize curvature, we can plot it alongside the original curve. Let's use Matplotlib for this purpose. This plot provides a clear visual representation of how the scaling factor influences the curvature. The blue line represents the original curve, while the orange and green lines represent the curvature with scaling factors of 0.5 and 2.0, respectively. Notice how the orange line is flatter than the green line. This demonstrates how the scaling factor affects the bending of the curve. In this tutorial, we learned how to calculate and curve curvature in Python using NumPy and SciPy libraries. First, we introduced the concept of curvature and its mathematical formula, and then we implemented the code in Python to calculate the curvature. We also explored the significance of the scaling factor and incorporated it into our code. Finally, we visualized the results using the Matplotlib library. Remember to experiment with different curves and scaling factors to gain a deeper understanding of curvature manipulation. Like the video and subscribe to the channel for more such tutorials. Also, check out the website delftstack.com for articles on Python tutorials.